How about now? Can you hear me okay now?
Good now.
All right, there we go. Always, even when testing right before getting started. So let me go back to screen share here real quick. Hopefully you will see the title slide and can still hear me and can still see my face, which would be the trifecta. So we are going to be chatting a bit today about measuring quality in production. It's a fairly kind of small group. I'm here to have a chat and not to try and preach. So I've got the chat window from Zoom open. And so if you have any questions as we go along, please feel free to throw them into the chat as we go. And I'm going to do my best to incorporate answers to those as we go, because I don't want you sitting there on a question, not understanding stuff, when I can try and get everybody back on the same page as quick as possible. And also still have some time for questions at the end. So measuring quality in production, if I say that the long story short is that there's nothing actually new for us as testers, obviously then there's a question of what the heck I'm going to be talking about with you for the next hour. And so to talk about production, we do need to go through some amount of setting of standards across conversations with DevOps. So I'm going to spend a bit of time talking about testing in DevOps, just briefly, as well as why DevOps, the key to testing in DevOps is so much about building confidence in our release as we go through a pipeline. And revisiting the fact that we actually accept a lot of risks as we release in this world. But I want to kind of call those out, bring those back to the forefront of the conversation. And that's what really sets us up for the conversation around possibly new terminology for us around SLIs, SLOs, and SLAs, which I'm going to go into deeply. I know that three-letter acronyms can be frustrating. And then kind of wrapping up with where we will fit into this world of this new terminology, this new conversation with our operations teams. And so that's kind of our schedule today. As I said, I'm going to be briefly touching on some things early on that if you feel like you have a strong disagreement with or misunderstanding around, it makes sense to raise those as questions early so we can all be on the same page. So don't hesitate to speak up or put something in the chat. But let's kick off. So DevOps Cycle, really importantly, is talking about developing and operating of software, more so than of developers as people and operators as people. And so Dan is much better at this whole drawing of models thing than me. So I always attribute, but also always steal his models. So here's an example of one of his models to call that out about how DevOps is the cycle of planning a change, introducing that change in code, seeing that go out to production to our users, and then monitoring our users in production and having each of those steps feed into the next. You are only seeing a title slide, huh? Interesting. Well, thank you for throwing a chat out there. I appreciate that. I am seeing it change on my side. So I'm going to stop screen share again real quick and try and share my screen in a slightly different way. All right, so hopefully now you are seeing the DevOps cycle. I'm going to try and change screens back to my description of what I'm going to be talking about and see if that also changes screens for you. Hopefully now you will, cool, all right. So now you can see that I've already explained this, so I'm not going to spend time on it, but this is going to be what we're going to talk about today. Yes, like magic, our screen share is working now. And so that cycle I was describing verbally before, here from that magical model from Dan, is a continuous cycle, and it shares things, information from stage to stage, including feedback from what's happening in production with our users, back to planning new changes that we want, whether that be bug fixes or new features. And Dan takes this model one step further and actually says, where do we test in DevOps? And an ideal test strategy is, well, everywhere, right? So we talk about this a lot. We want to test ideas, we want to test implementations, and we want to test that it's working in the environments that matter with our users in production. And I say that this is the ideal test strategy in a DevOps world because we talk about this all the time as well. Ideal test strategies can never be everything everywhere. It is cost prohibitive to try and test every single thing before we release software, or even after we release that software, right? We have to kind of spin these webs of trying to catch problems in a cost-effective way as early as possible so that we can try and limit impact to our users, catch the really important things early, and get fixes out for the things that are maybe less costly after maybe they got there. And so this is something we talk about all the time: risk management. What do you want to test for? What do you want to spend time on? And what drives those decisions are more models of how to prioritize our efforts, what kind of techniques we can use, what kind of information that we can apply, and how we want to share that throughout. And so we take these models of what kinds of things we can test, how we can test those things, and we apply them back to that cycle of DevOps. And so we iron out that cycle, because even though it's continuous, it is also in a flow, in an order. And we can say that we can apply our testing to planning, to writing of code, to releasing that code, and to seeing it run in production. All of this hopefully is stuff that you've kind of read about, maybe even used around DevOps cycles of testing. And so for the kind of next step, we're going to dive into one particular approach to testing. I'm a huge advocate of exploratory testing. I'm a huge advocate of testing in lots of different ways. But automation is a huge part of DevOps, because when we talk about the release of something through a continuous integration and continuous delivery pipeline, the only guaranteed validation is that automation. Because that is the only thing which is repeatable. That is the only thing which has documentation done by computers where you can see exactly what they've done, and it's not filtered through the imperfection of humans, myself very much included in that imperfection. And so when we look at that DevOps cycle and we look at the fact that automation is our only guaranteed validation, what we're talking about is that pipeline which we run in tools like GitLab, tools like Jenkins, and so on. And those tools cover only a part of this cycle. They cover the merging of code changes out to the build and release of that to our customers. And these pipelines can get, even though they're only covering a small part of this cycle, can get quite complex, right? So here's an example of a pipeline in our organization, which covers the most kind of large and complex piece of software that we have. It's also the most important piece of software that we have. It's 15 years old, and it's the workhorse of our website until we start breaking it down further. And so to make changes to this, we have introduced 61 different jobs. These can range from deployment jobs to testing jobs and building jobs, all things that need to be done to the code change to validate it's ready to go out to production. And those 61 jobs run across 19 stages. So the stages are the vertical columns. You can see that in some cases we have much larger stages, a lot more jobs in them. And in some
I'm trying to reduce that.
I'm sorry? Oh, sorry, I thought I heard something there. But yeah, so we've got lots of different stages, lots of different jobs, and it takes us 2.5 hours, which is a huge time commitment and a huge commitment by our developers as well to keep these stages working efficiently, giving good feedback, responding if any of these break. This is a huge investment for us, but it's valuable because we're catching all sorts of stuff. So what are we trying to catch before we get to production? We're trying to look for our expected behavior is, well, operating in an expected way, and that we're not regressing. And we're doing that across a fair number of different aspects of our website. It's business logic, it's error handling, its performance can be built into this, code readability with things like linting and test coverage suites and things like that. We've got security that can be in some ways checked, in other ways that needs to be done manually. Cross browsers, third-party integrations, visual alignments. And this is by no means attempting to be an exhaustive list. I just wanted to try and cover some of the most common use cases, as well as a broad set of use cases to try and tackle in a pipeline. So we've talked about the fact that DevOps is a cycle. We've talked about the fact that a CI/CD pipeline can help validate the merge to build and deploy part of it. How do we build confidence in this pipeline? Like when we're testing all these things, where do we put them? And we build confidence ideally doing so as we build complexity of the environment those tests are running in. So this is where we start to, I think, diverge from very kind of common knowledge to things which maybe some people are doing and some people are not yet focusing on. So within this pipeline, deciding what to test when, where, should, in my opinion, be done based on the new opportunities presented to you at each stage. So at the first stage, when we're just building the software, we don't have an environment, we don't have the ability to run the software yet. We just have basically bytecode. So what is it that we want to validate there? We want to validate compiler problems. We want to validate static dependencies, things which can be done at that very low level. And we ideally don't want to be testing any of that ever again. So once we've built this, once we've tested that it works for those things, we don't want to retest things at that scale, at that scope, as we get further along this pipeline, because we should be done. We should have trust. So then we go into actually having our packages ready to be deployed. But even before we deploy them, we can do a lot of validation. This is where we can run our unit tests, as well as things like mocked integration tests or contract tests. Things that don't actually require the running of software, but can still give a lot of really quality feedback about how our systems are working. Eventually, we run out of things that we can test at that level, and we go into a deployment. Now, this first deployment in itself is testing something. It is testing our operability for the first time, our ability to release. But just like that build stage is doing only the most basic of testing, so true with this, because there's only so much which you can test in these usually very primitive environments. They're often on very different infrastructure than your production would be, and at very different scale. They're quite small usually in comparison. But now we're live. We've got the access to this website, so if we're talking about web app, the browser can now hit it. We can do API testing. We can do proper integration testing over the network between our different services. And we should be doing all of that. Now, ideally, we're not rehashing the testing that we had done previously, so we shouldn't be testing the internals of any one of our services, but more tackling the communication between those services. And so we're continuing to build confidence in this release. When we're done with that, now we're realizing that this environment is not quite what we're going to be releasing to in the future. So let's deploy to something a bit closer to production. And so people might call this staging or some other variation of that name. Now, this environment, you're probably going to be a bit better test for your operations. There might be a larger scale to the environment where instead of only releasing a single version of your application, you might have a replica so you can serve more traffic, similar to how you're going to handle production. That is complexity. That is something you need to test and validate. And so that is being tested during deployment. And once you're in this larger environment, you now have the ability to do things like performance tests and UAT tests. At this stage, we hopefully aren't finding any problems with the business logic inside of a single unit or even between units. Hopefully we'll have found those prior to here. And we're testing more the overarching integration over everything and performance of it until we finally deploy to production. And the reason I say that this is the real deal and that this is the first time you're actually testing the proper things is because it's true, right? So let's zoom in on this real deal aspect of deploying to production and what I mean by that. And let's be honest with ourselves about how confident we might be with the release at this stage. When we get to production, we do still have risks impacting us. The scale and the exact contents of our data will not have been replicated prior to production. If you are able to run exactly the same scale in production and pre-production, you are running at such a small scale that the impact is probably quite low if things get found in production. Realistically, this is not something that organizations can do at a cost level. And also the poor environment, if we were running enough servers to do that for everybody, right? The exact content of data, right? With GDPR and personal information, we're not having the exact data in lower environments that we have in production. And so all of a sudden we might find some edge cases in there based on data that was introduced ages ago. Networking, super common errors in some of our most popular software these days are coming from things with networking problems, configuration problems, or content delivery networks with caching of information at the edges. These are all things which cannot be tested prior to production. You can try, you can poke at it, you can challenge it, but in reality, you're going to be releasing to a brand new network when you get to production with a brand new configuration and with a brand new CDN. And always, we just have to admit that users, there are more of them than there are of us. So no matter how creative we can be, they will do something funny, right? And that is something that we're gonna only be able to find in production to a certain level. And again, I'm not trying to be exhaustive here, but I'm hoping that this is enough examples to maybe get people on board with the fact that testing in production is something that we all already do. Just some of us are actually doing it actively, proactively, and looking at the results of what's happening in production. And some of us are maybe putting a bit too much confidence in that pipeline to get to production, and we're maybe not accepting these risks, even though they exist on a release. So if we've got these risks in production, and if I say some people are being active about testing these risks in production, then we've got to have techniques, right? So some of the techniques that I've seen people apply and that I've personally applied to production are these, right? So we exploratory test in production. There's nothing that says the techniques that we use pre-production can't be reapplied. And absolutely, I go on our website all the time as a user, trying to see how things are impacted by changes we've put into place. We use our feedback from our customer services teams to understand how they're getting impacted. We do what's called synthetic monitoring. And so this is basically sums up running our automated tests against production. And this is like kind of an ongoing process. So, hey, can we check out? Hey, can we, for my company, I work at Moo, we design business cards. Can we design those business cards? And then we also apply some white box monitoring. And what this means is we keep track of how our services are operating. Are they under heavy load? Are they working really hard? Are they actually returning good responses, like 200 responses, or are they returning errors? And this is all stuff that we can do in production. But there are limitations to each and every one of these. For example, with exploratory testing, we still have the limitation of our imagination. There will be complexities that users identify that we could not have imagined, right? Within any reasonable time frame. With customer contacts, of course, this inherently means that there's been impact to our customers, and probably at a fairly decent scale, because a large number of customers will never reach out when there's problems. And the customers that do reach out, our customer service team needs to decide, is this something that is a big problem? Is this a one-off problem? And so often, by the time it trickles down to tech, this is something where there's a fairly decent impact. With synthetic monitoring, with that automated tests running against production, we can, again, only test what we can imagine. So yes, we're doing it more consistently and reliably, but it's still what we've imagined and what we've been able to automate. And with white box monitoring, this is where we're starting to blur that line to operations. And I can, as someone who's currently working in kind of an operations-oriented team, I can tell you that what the big issue here is that we're looking for previous causes, and they're binary. And so often we're looking at things that have caused outages in the past, but are not actually the impact our users are feeling. So a great example of this is CPU. If our machines are running really hot, they're working really hard, the CPU is really high, do we care? Like, we want to run as hot and as hard as we can and work our machines as hard as they can, because it costs money to put in more machines. It costs money to have more CPU. But there is a limit to that where it does start to impact our users. So is CPU a good enough proxy for our user experience? That's a question, right? Again, this is a limitation of white box monitoring. So with monitoring as well, we sometimes talk about, well, actually, I want to stop there for a second because I've now been babbling for about 20 minutes, and I had already let you know I was going to move fairly quickly through the beginning stuff just to make sure we were on the same page. So are we on the same page? Does anyone have any questions right now about this or any arguments? Do you disagree with me in some way? Go ahead and throw it in. You can privately chat me if you don't want to do a public chat, or feel free to do a public chat. I'll give you a minute if you have questions. Fully agree, watch out. My head's gonna start to grow on the screen right now, so cool. Is this something that people have done? Like, so when you say you agree with this, is this something you agree with, or is it something that you're actually doing as well? That'd be interesting to know. Why is the cost of the main concern for now? Can you explain more on cost? Cool, so I think what that's referencing is when I say we can't test everything because it costs us too much. And so I've used cost in two ways. So that was one way. The other way I used cost was around the inability to run a proper, like, duplicated environment of production, because the scale of production to run it twice costs a lot of money, right? So I'll speak briefly to both of those. So the cost of testing everything is a conversation that would be an hour talk all on its own, right? Is what is the cost of delay to getting that change out to production? If we want to, if we have competitors, which most businesses have, and again, your context matters. If you live in a closed world where your competitors don't exist, this might not apply to you. So I just want to call that out. But in a world with competitors, if we are trying to maintain and grow our customer base, we need to introduce opportunities and features at a pace faster than our competitors to keep our customers happy. The more time we spend on testing, the less that pace can be. So we need to be aware of that. When we start talking about cost of environments, as I said, running servers are dollars per minute, right? And if we're serving traffic at a large scale in production, trying to run an equal amount of traffic outside of production, you can look up calculators around what the environmental impact of that is, as well as the monetary cost of that. And it's not really something that's feasible at any given scale. Hopefully that helped, Denise. So then we said, can you mention how this approach might work in microservices? That's a great question. And that's exactly why this approach is required, right? Because with microservices and having things have to talk to each other and there's configuration of how those microservices talk to each other. And at the staging level, the identifier for microservice A and microservice B is potentially tied to being in that staging environment. And all of a sudden you need a different identifier when you get up to production. And is that identifier correct or not correct? And so microservices is also a great example of how the next slide that's coming up, which I'll just switch to now, might as well, is that our systems at this stage are never completely up or down anymore, right? The idea of a brownout, of partial outages, is much more common. And so we need to be aware of these in production, because a partial outage in staging, is that a fluke? Is that a problem? I don't know. In production, it is, and we need to be aware of them. So yes, this is a great approach for microservices. What about having a group of beta testers, an actual subset of customers? Yes, this is great. So that is a great example of another technique you could use for testing in production. Terms that you may want to search for to understand more about this if you're new to the idea is a newer term called progressive delivery, or progressive deployment. And a more kind of seasoned term of canary deploys, where you can choose to send traffic to only a subset of your users and see how they're impacted. Now, of course, you can pick those users to be maybe internal users before you send it to external users. You can pick maybe some of your customers who have signed up to be beta testers before you send it to your wider audience. You can do things to really de-risk there. So fantastic, another example of how to test in production. If you're, got at least one person already doing this, so this is fantastic. So if you're running your machines hot, how do you calculate additional load monitoring adds as a part of the hot running? Really good question. And this is something that does need to be evaluated at scale. And so this is something that your operations teams should be evaluating. I am not going to dive into some of the techniques right now, but you will tend to offload metrics and logs to separate processes that can be run in lower risk times, as well as less frequently, as well as you're willing to drop them more. So using networking techniques that say prioritize our customer traffic over our metric traffic. So these are all some things you might do. So things these are doing in the 90s and 2000s, absolutely. That's why I'm saying this is actually not new stuff. I'm not coming out here saying I'm some brilliant person introducing a brand new idea. These are things that have been used on and off over many, many years, and they're just becoming more popularized now. And hopefully more popularized within the testing community, which I think is the new bit. Great, so inconsistent. Yeah, best intentions can be hard. Maybe this, cool. Any tips on people understanding the real value of testing in production? Teams tend to think that they are done once it's deployed. Yes, this is a continuous challenge of mine. And one of the big things is about ownership of production. And again, a whole other hour talk, but what I would throw out there to think about is there's a lot of conversations about who should be on call for production services. And there's a lot of ways of doing on call in a creative way. So not all engineers should or want to be on call overnight and over the weekends. But what about being on call when you're at the office? Getting an idea of what outages can occur when you're making deployments during business hours. These are ways to maybe try and connect your developers to production and test more in there. Cool. So that's a lot of questions. I hope I've answered most of them. I probably missed one. I did a little bit of scanning there. So please re-ask. It wasn't intentional. But I am going to go on because now we've got getting to this new bits of what we're doing with operations, which I hope you all will be interested in. So as I mentioned in the answer to a question, our services are no longer just up and down. There's no longer one web service serving traffic either successfully or unsuccessfully. We have this net of microservices, and we need to be creative about how we test that. And this change from monolith to microservices is why our operations counterparts have been getting more and more creative about how to evaluate quality in production. Because for many years, and still today in many organizations, these operations engineers are being thrown over the wall and told, make this run for our users. So despite DevOps being development and operations, we still think about it in many organizations like developers and operators. And so our operators have been getting smart. They've been thinking about quality, just like we have, just from a completely different angle. And what they've been really popularizing today, and again, I'm not trying to say that this is brand new. It's been around for a long time, but it's been getting popularized service level language. And so I want to dive into what these are. And then, as I said in our setup, I want to dive into where I think we as testers can get involved. So service level agreements. I think this is the thing that you probably have seen before, or most likely to have seen before, is an SLA. And I want to take an SLA here, and I want to break it down into its pieces, because it's really important to understand what makes this up. And so here's an SLA that you might imagine someone would have written for old school Netflix, right? Netflix, where you have to send out the DVDs by mail. And it says the correct movie will arrive within 3 days, 90% of the time, or else subscriptions will be discounted. Okay, so let's break this down piece by piece. The first piece I'm going to pull out is that the correct movie will arrive within 3 days. This is a metric that tells you how your service is operating. And the key here is that it's how your service is operating from the perspective of your users. This is not about how we shipped it. This is not about how we picked the movie to ship. This is about the end user getting the culmination of all of those activities and being happy with that result. We're saying we want to hit this 90% of the time. There is a proportion of time here that we are targeting. And I'm very explicitly not setting it at 100%, because no SLA can be 100%. There will be problems. There will be a blizzard. There will be a mistake done in the warehouse when picking the right movie. And what we want to set is a level where our users will accept it. They might not be happy. We might have to talk to them in customer service and still give them a bit of a discount or a bit of a free movie in the future, kind of customer service stuff. But it's setting an expectation with them that we won't be perfect, but we expect to be pretty damn good at 90%. The last bit is the punishment of what happens with if we don't hit that. If you as a customer or do not receive 90% of your movies within 3 days and as the correct movie, we guarantee you that we will discount your subscription. Sure, if we hit 95%, we still might want to be nice and give you a discount, but no guarantee. But if we're below 90%, guaranteed you will get a discount. Okay? So these are the different bits of the service level agreement. Cool. So when we talk about an SLA, what we're talking about is a promise made by the company publicly to our users, and that there is explicit retribution that will be given if that promise is not kept. And so the example for a movie delivery service being that they will give a discount if they don't serve the right movie within a certain amount of time, within 3 days. The reason it took me 3, 4, 5 slides to explain an SLA is because there's actually a lot of complexity around SLAs. They're actually built on many other little pieces, and they're really just the tip of that iceberg. And this is where I think it's most interesting to get us involved as testers. An SLA is the penalty associated with a missing target. An SLO is everything the SLA is without that penalty. And so an SLO is the assignment of a target success rate. But for there to be a target success rate, you have to know what your success rate is. And so an SLI is the metric that identifies if the service is operating. Gonna dive in a little bit deeper. I'm still using 3-letter acronyms. Promise I'm getting past those on the next slide. So we step down from the service level, the SLA, and we're saying, okay, what is our SLO? What is our service level objective, which does not have a user-facing penalty if we miss it? And this is really important because it's kind of a sibling to the SLA, because it's how we want to run our metrics. And we do our metrics and our calculations in the exact same way. But this is often something that's only internal to our company. So if this magical movie delivery service had a 90% SLA, so promise to our customers, we wouldn't want to be tracking ourselves against 90% because we'd be far too likely to have a problem occur, right? To dip into that. We'd want to track ourselves a bit more aggressively than that and find problems maybe at 95% so that we can preempt any risk of missing that SLA. A really key conversation about SLOs is that they're a target you want to hit. They are not a minimum. If you are running at 100% success rate, sure, get yourself a cake. And then also you might need to look at yourself pretty hard in the mirror about if you're taking enough risk. Are you making upgrades to your systems at a fast enough pace to keep up with the industry? Are you adding features at a fast enough pace to be competitive with your competitor companies, right? So we set this as a target because we want to have a thing called an error burn rate, where we're allowed to make errors for a small amount in order to reap the benefits of that faster change cycle. All right, so keep that in mind, it's targets. And finally, the status objective is conversation and reprioritization. So, I talked about this for a second. If you're way above your target, maybe you need to start moving faster. Be less risk averse. If you're getting close to your target, or especially if you're below your target, maybe you need to push back on that product team a little bit and say, hey, we need to do some reliability work real quick before we can do any new features, because we're going to start really impacting our customers soon, right? So this is how we can start prioritizing. So We got our SLAs that have punishment associated with them. We've got our objectives, which are what we can use for prioritization within our own company for how successful we're being. But both of those are built on the foundation of an indicator. So service level indicators, or SLIs, are the workhorse. This will define your ability to be accountable, because you need to build metrics that actually matter to your users. Most commonly, these are a combination of uptime, so is the service even running? Availability, is the service able to actually serve traffic? So not only is the server there, but our software is working as we'd expect, and that the quality of service is what we expect. If we're just spewing back errors, like sure, we're available, but we're not very helpful. And so what does quality look like? Is it just a successful response? Is it a successful response that has the data in the format people want, in the type people want? This is something you have to really dig into what it means for your service. But whatever combination of those things you pick, the ideal is to have this boil down to a, yes, this was successful, no, this was not successful, on a kind of per request basis, so that you can calculate percentages off of it. And keep in mind, you can have multiple indicators which combine together to say, is this an objective that we want to meet? So you might have an indicator around uptime separately than an indicator around availability, but combined, those make an objective. So that's okay. All right, so the last bit, I have very little left, but the last bit I want to talk about is how test engineers get involved in this. So while I'm on this slide with kind of summary definitions, I want to stop again. I've seen one question come in, so I'll read that, and also give time for any other questions about this, because this is really the meat of it, is understanding what these are. And again, you might already know this, and I'm sorry if I'm preaching to the choir here, but I've found that these are new terms for people in the area a lot. So throw in some questions if you have them, or thoughts if you're using this and how you're using it and what's difficult about it. Feel free to do that as well. Any thoughts on how ops run by third parties can change the challenges you've outlined? Yes, so I think, Sandeep, that you're asking, like, if you are relying on a third party. So like you have an API that you use. For example, at Moo, we use shipping companies, right? So we have like DHL we ship with, or USPS or whatever. And what does that look like? Cool, thank you for confirming. Yeah, this is really hard. But what I would say that we've learned is that an SLA is a best effort by a company. And sometimes they don't even know when they're missing their SLAs. So one of the things that we've found benefit in tracking our interaction as the customer with our third parties is that actually we can poke them and we can say, hey, yesterday you told us that you were going to operate at this kind of a response time or this kind of a success rate, and we were getting errors everywhere, and it slowed down our manufacturing department because they were waiting for responses from your API. And we've received retribution from some companies because we've been able to prove that we didn't get the service that they promised us. So you can't always get access to their data. That would be ideal. But keeping track of them is just as important as keeping track of yourself. Keep them honest, basically. Yes, so Denise is saying that there's some challenges with getting everyone to agree on the 3 levels. I totally agree. I was actually just on a call right before this with our business intelligence team, and they are brilliant humans who know a lot more about our customers and about our data than I do. And what we were hashing out was, what matters? Like, why are we measuring this stuff? Because if you start with an agreement, if you start with, we promise our customers that we will be successful 99.9% of the time, like, what does success mean? Like, is it across the entire website? Is it, just latency, or is it just error rate? And so we really dropped ourselves down. And what we're doing is we're building ourselves up from the indicator level. We're making sure we have a grasp over what success looks like, what success means to our customers, before we start talking about how often that needs to be done for our customers to be happy. So if you want alignment, I would suggest starting at the bottom of what matters. Cool. Well, thank you everyone for engaging. Like, this is awesome. Like, sometimes you're talking to the void here with online events, so I appreciate it. But let's get on to that last bit that I've promised, which is that I think as test engineers, this is a space that we can and should be playing in. All right. Some ideas I want to encourage us to think about is that we have exploration and user-focused skills already. If you're already participating in maybe behavior-driven development, BDD, or identification of bugs and how to do reproduction steps and how to do all those things, you have a perspective that you can help the operations engineers who are maybe deep in the Linux code and deep in the metrics data and stuff like that, to pull out a bit and really get involved in where you see the hot spots in our applications and how you can define these things. BDD scenarios are, I mentioned, are a great way to drive out SLOs. Like, when you think about your scenarios of someone should be able to check out, okay, we do that, we talk about that, we document that in some way, we potentially automate that in some way, and we run that automation prior to release. Who's saying that's successful in production? Maybe you're running synthetic tests of that scenario through production to validate it's correct. Cool. I'm so glad that your bot can successfully check out. But what happens when your number one customer can't? What happens when 50% of your customers can't because they're having a problem with the content delivery network over a certain country is having caching problems or whatever the problem might be, right? Take those BDD scenarios and apply them to metrics about our real users and get feedback on the core scenarios that you have, the money paths that you have throughout how our users see our systems. This is what I would advocate for or suggest trying. This is also, Denise had the question about how do you get people on the same page? You talk to them. Like it's the hardest part, but it's also the key part. It's always a human problem. It's never a technical problem. We talk about three amigos in the testing world all the time, getting testers, developers, product owners together. Why can't we do a three amigos around what success looks like in production to our users? Why can't we get an operations engineer and a customer service agent and a business intelligence specialist together with a software developer and with you as a tester and have a conversation about what they care about and what they wish they had proactive information about rather than reactively getting bombarded on the phone lines as customer service? And another place where you can use your existing skills is if you have automation and DevOps skills, if you're already writing test automation, if you're already helping with pipelines, why not get involved with how we write metrics, with how we write logs, with how we can generate this data and dashboards and things like that around it? These are all just a very small jump from what you're currently doing if you are currently writing code. But I left that one to last because it is not about writing code. This scenario does not require writing code. You can do so much more without it. So, wrapping up, as I said at the beginning, and yet I still babbled on for 50 minutes, there's not a lot new here. We can use our existing skills and our existing ways of working, and we can just extend them out. We can use service level based monitoring and learning, which gives us the ability to monitor for and wake up for on-call engineers, wake them up on what matters to our customers rather than on some metric about a server that doesn't impact anybody in real life. We already talked about this in testing when we talked about moving from coverage-driven metrics to benefits of context-driven metrics and things like that. Why can't we help our peers in operations to go on that same journey, right? We have lessons we've learned. Monitoring our features in production is an extension of trust, trust but verify. Sure, we've run our automation tests. Sure, we've exploratory tested, and we think that our features are working, but let's make sure they're working for the people that matter. Let's verify that. And SLOs being written in collaboration with business and operations is the three amigos that I mentioned on the last one. So why can't we get involved there? So this is my kind of challenge to y'all, is take your massive amount of testing skills and help our customers and help our operations teams use similar techniques for benefit as we go. that's all I've got for you today. So we've got 10 minutes left, and I've seen a couple things come in. So I'm gonna view the chat real quick. Keep them coming. And also, I have no problem if you want to unmute, if you can unmute yourself and speak up, feel free. This is now free for all question and answers and thank you time. So. Interesting question. So we've got a question here on if metrics don't exist yet, do you think it's a responsibility of test or ops to set up monitoring? This is a really tough one and it's going to be organization based. If I say a super generic response, again, put it in your context, I would say that the ability to collect metrics and to have those metrics stored at scale and to have those metrics be queryable should fall to ops. However, ops can only ever get the most basic of metrics for you. They can only ever ask for server metrics. They don't know what your business context is. So an example of a metric that we have that software engineers have put in place is we have a metric of purchases per minute. How many people have actually purchased something? You can't do that when all you're talking about is operations and networking and that kind of stuff. But when you're talking about when you're in the software, when you're in the method that literally says successful purchase, you can add a metric to that method that says every time this method is called, count one metric as a purchase. So it's a shared responsibility, in my opinion, between the capability, which is operations, and the quality of data, which I think would fall to, in my opinion, software developers, just like I think automation should fall to software developers, but in collaboration with test engineers. With third-party dependencies, how do we translate ops metrics that prove they are not delivering on SLAs into human-readable format for consumption? The sentences would be my hope, right? So the sentence I wrote about that we hope that we deliver the correct movie to people within 3 days, 90% of the time, seems like a reasonable thing for a business to understand, to grok, to pay attention to. Now, the nitty-gritty underneath there can be very, very detailed and very techy. But when we get up to that level, it should be a sentence where you can just plug in numbers. Like that 90%, we can say we are currently servicing customers correct movies within 3 days at 85%. We would like to, our SLA is to target at 90%, right? Just kind of write that as a sentence. Are there any resources to find out more? This is an exploding space right now. So the best resources are actually blog posts at this stage. I can try and throw some stuff up on my Twitter. There is a book coming out shortly. They have a pre-release of it right now on the O'Reilly website around service level objectives, which is by a gentleman named Alex Hidalgo, who I should call out because he's given me a bunch of help on getting some of this stuff ready. And that's going to be a fantastic resource once it's out. I've seen the pre-release on O'Reilly and a couple of other bits of it. In addition, if you just do a search online, you'll see tons of articles around how these get calculated and how they can be applied. One of the biggest resources is Google, the Google SRE book, so Google Site Reliability Engineering. They released that book online, so you can read that there, and there's a chapter about service level objectives in there as well. So it's a good place to start. Cool. So aiming for a test architect is, so deciding how to set this up might be part of architecture, but being engaged in it, I think any individual contributor can and should get involved. Absolutely. Cool. And then some thank yous, which I really appreciate. Again, I feel like I'm shouting into the void a lot when I'm doing this stuff. So I really appreciate that you all have been so active on the chat and sharing your own experiences as well, which is super key. So I've got 5 minutes. I don't want to waste your time. I also don't want to steal 5 minutes from you if you have more questions. So I'm still around if you've got anything else. Or any feedback. This is a brand new talk for me. I'm going to be giving it some portion or some version of this again in a couple weeks. So feel free, again, you can private message me here in Zoom or on Twitter if you've got any things that you think were a bit confusing or particularly valuable. I would really appreciate any of that feedback. Fantastic. All right. Billy, I think we might be good.
Good stuff. Well, yeah, great talk. Really good feedback. Can see the loads of messages popping up, which is great. And thanks for continually asking everyone's questions throughout. If anyone's got any further questions, how would you want them to reach out to you? Is it via Twitter?
Yeah, Twitter's gonna be the easiest way. I've got open private messages, so you should be able to get to me without having to follow me or anything like that. This is not a ploy for any of that stuff. But that's probably your best way, for sure.
Good stuff. Well, huge thank you, Abby. Thanks everyone for coming along and continuing to be part of Quality Advocates. We've got another 3 events next week, so definitely check them out. But make sure you all get out in the sun today and enjoy yourselves. Thanks very much.
Absolutely. Thank you all. Have a great day.
Cheers, guys. Bye-bye.